Hello, we're back. So I did warn you guys that it was gonna get harder from the budget line and the IC curves, right? So now we're actually combining them into one graph. Because economics, we love graphs. We love graphs in economics. And all we do is we just draw them and we analyze them. It's theory, and it condenses a lot of information into a nice condensable graph. So as you can see, there's a budget line, the straight linear curve, that's the budget line. And of course, the bending one, the one that goes convex, is the indifference curve. Now, as you can see, I made a point. It's called point A. So, point A is where the indifference curve and the budget line is tangent. That is very important. You gotta understand. Tangent means they have the same gradient. And of course, we know that in consumer choice, we have limited income, meaning using that budget line, we need to allocate our limited income between, let's just say, two goods that maximize our utility, because rational customers, rational consumers want to maximize their own benefit, their own utility. And so the best way to do that is by, of course, making sure it aligns with our income. So we're spending every single dollar we have to give us the most benefit. You don't want to waste your benefit. You don't want to buy something you won't use. So of course, you got to buy something that you like and that'll give you the most satisfaction. So this is why we have the indifference curve and the budget line on one graph, which of course I know it can be a little bit hard to understand, but yeah. Now, the reason why I say it has to be tangent is because if we had an indifference curve up here, let's just say, then of course, yeah, we could, theoretically, we could consume at that point, but this is one issue, our budget, our income. We don't have enough income to do that. So of course, we don't. We can just, that's just like our point here. We can just dream about consuming that. And then at the same time, there's a curve over here, right? What's the point of consuming here? Just inefficient. We have more money and we can maximize our utility more. So which is why I say we should go at A. Now, if we had a curve and they were intersecting at 2 points, let's just say here and here. Now, these 2 points, they are both on the indifference curve and they are both on the budget line. But just like in the first episode where I talked about indifference curves, if they are they're both on the budget line, we cannot say which point is better than the other, because they both provide the same level of utility, just that they provide different amounts of goods of X and Y. Now, of course, you can talk about the middle basket and everything, but they're both equal, basically. So it doesn't really matter. Now, this is where it gets really important. So we already spoke about, the marginal rate of substitution, which is basically the maximum willingness that a customer is willing to give up one good for another, or substitute one good for another, reflects opportunity cost and preferences. So we have so many formulas. We got the marginal rate of substitution, or the MRS as I abbreviated, is equal to the partial derivative of X over the partial derivative of Y. And this is important for formulas like if you get utility. If you get a utility function u of x of y, then we have to get the partial derivative of this, or we can just write that as mux. But I'm going to get to that part a little later. So that's one way of doing it, mux over muy, or the partial derivative of x over the partial derivative of y. Another one is, I think the more common one that we used in the beginning at least, is minus the change in y over the change in x. I think that's kind of obvious, and we already explained that in a previous video. And the most important one that we got to get to now is the marginal rate of substitution is equal to the price of x over the price of y. We spoke about this last time, if you remember. The budget line gradient is minus the price of x over the price of y. So this, I mentioned that also, it's called the price ratio. It's essentially the market exchange rate between both the goods. It's like if y costs 2 and x costs 6, then that must mean that each x costs 3 compared relative to 1 of y. So basically, whenever you buy 1y, you're giving up 3x. It's like that. It's the exchange rate. That's why it's called the price ratio. And here's the thing. You might be wondering, okay, why can't we consume it at a point where they're not equal? Okay, this is where we get to more of the specifics. So first of all, what is the MRS? Okay, so the MRS is basically how much of Y you're willing to give up to consume 1 unit of X. Now, in this case, that means that if your MRS is less than the price ratio, that means that you value X over Y, and you're gonna keep consuming X. Now, what's the point? Remember, we have to maximize our own utility. If, let's just say, we're talking about, let's just say, apples and bananas. I love bananas. No, sorry, apples and bananas. There you go. I love bananas. So I'm gonna keep buying bananas because it provides me more utility, and therefore my MRS is less than the price ratio. I'm gonna keep buying bananas until I get to an optimum level of apples to bananas relative to my income, of course. So let's just go back to that. If your MRS is less than the price ratio, you value X over Y, and you're gonna keep buying X because you have an incentive to buy X. Now, on the other hand, if your MRS is greater than the price ratio, you value Y over X, meaning you're gonna keep buying more of Y. 1 second. Yep. So now, obviously, the only way you're gonna stop buying X, stop buying Y, is if your MRS is equal to the price ratio, meaning your personal trade-off is equal to the market exchange rate. Essentially is what it means, which is why I wrote it in big. Now, let's just go back. Not since we're talking about the MRS so much, I might as well go back to the indifference curve chapter. So the lower we go on this convex indifference curve, the lower the MRS is, which means we value X over Y. No, we don't. I'm kidding. And then the next one is if we go up the indifference curve, the MRS is more. Are we cool with that? Okay. By the way, that joking part, I was joking about that part. So, I think I'm losing myself. Sorry, it's like 5 p.m. here. I don't know why I'm so sleepy. Let's just go back. So, summarize what I just said. The lower you go, the more you value X over Y. And the higher you go, the higher you value Y over X. That's it, because the MRS is higher, and over here the MRS is lower. Now, we are going to talk about something really cool, and it's called a corner solution. As you can see, I've drawn 4 different curves. 1, 2, 3, 4. So, as you can see, they're a little bit weird. These are 4 indifference curves, by the way. I don't think I labeled them properly, but it's fine. So, you got 1, which is perfectly inelastic, perfectly elastic. It's rising very slowly, so they really like good X. And then this one is falling really, really slowly, very, very, very steep. They clearly like Y. Now, you might be thinking, okay, so what's up with these curves? What are you trying to teach me, Aston? So this is called corner solutions. Now, I did mention that the only way we can maximize utility is if our price ratio is equal to the MRS, but that's not always true. Because in situations like this, where you have these fuck-ass curves, then, of course, if we try to, equate our budget line to this, we'd get some random solution. So, what happens instead? This law, or it's not a law, but this rule doesn't apply. This rule is invalid, basically. This is where the MRS is not equal to the price ratio. They don't give the same solution. Now, the reason why this happens is because sometimes consumers prefer one product over another. There's multiple reasons for this, but I think 2 of the main ones are, first, brand loyalty. Let's just say I'm more of a Nike guy myself, and for basketball shoes, I will never buy Adidas. Like I said, I'm probably wrong. There are probably some good shoes, but I just like Nike shoes. I don't know. I've always worn them my entire life. And in the same way, you might have a brand that you really like. Let's just say Apple and Samsung, or maybe something else like that, something similar. Now you might have AirPods, you might have an iPad, an iPhone, and you'd think, even if Samsung was a lot cheaper, you wouldn't care. You would still buy Apple products, which I think a majority of you do have, and that's from the Apple ecosystem. That's another chapter of economics, by the way. And then another reason is veganism. You can be veg, you can be vegan. You will basically always buy something plant-based over something animal-based. Like if you're vegan, I don't think they eat eggs or they drink milk. Any kind of animal product they will not have. So essentially anything, they literally value anything, any kind of plant-based thing over meat, which is exactly where the perfect inelastic or elastic curves come in. Now, this is called a corner solution. Now, the corner solution basically means that the best optimal solution for the consumer is at the corner, because there's no point in consuming or even buying another unit of the good. It doesn't make sense. Why would a vegan buy beef? Why? What's the point? For what joy would they buy beef? Right? So your maximal utility will be on the corners, the edges of the axis. There. That's called a corner solution. I thought that was a really cool concept, by the way. So I just wanted to introduce that. Now we have another concept, which is called personalized preferences. Personal preferences or something. Now, let's say we have a nice curve like this. And we have a point A over here, and let's go another one. Now we have point B, and on this other curve we have point D. As you can see, in point A, the value of Y, of course, increases. The price of Y increases, which is why it drops, and the price of X will decrease, which is why it goes outwards from the vertical intercept. Now, assume that even on line 1, or let's just say it's called as budget 1, budget 2. Now assume that they're on point A, but they could be on point B, because B is on both line B, like the budget line 1, budget line 2, but they still prefer A over B. Okay, that tells you something. A over B. All right, that's cool to know. Now, after the price changes where X falls and Y rises, they prefer B over D. Okay, Aston, why does that matter? Because sometimes we're not given their indifference curves. We don't know their indifference curves or their utility or anything like that. So instead, we analyze their behavior. We see what happens. Okay, if they have the same level of income and they prefer point A over point B, but when it drops, they prefer B over D, we can clearly say that because of the law of transitivity or the assumption of transitivity, we can say that A is preferred than D. They would rather be at point A than point D, meaning any point below to the left of B, to the left of D, to the left of A is bad utility-wise. They would not go here. Meaning that the good point will have to be in the upper right quarter of all these curves. That is where you know it's going to be here, essentially right here. Plus, minus. There, that is their real preference. They would prefer to be on the top right corner. Any point above A to the right, they prefer. We could also say that to the top left, they might prefer, but we don't know. We don't have enough information to make that assumption, which is why we say right or bottom left. That's it. Those are revealed preferences. Now, I want to talk about another thing, and that's going to be marginal utility. So, first of all, let's talk about marginal utility. So marginal utility is marginal as in the name, meaning it's basically the benefit gained from consuming one additional unit of a good. That's what marginal means. One additional unit. That's what it always means. Marginal cost, marginal revenue, etc., right? So total utility is the total satisfaction gained from consuming a combination of goods or a good. Now, this is important because we have this thing called the law of diminishing returns. Now, imagine we had a curve like this. Okay, what kind of curve is this? Actually, we don't have to imagine it. This is a real curve. So, basically, the more you consume a product, the less you will enjoy it utility-wise. Now, if I told you, imagine you're thirsty as hell. It's a hot day or something, and then you're like, oh man, I could kill for a glass of orange juice. Guess what? Don't have to dream. There's an orange juice stand right there selling free orange juice to people. I don't know why it's free, and why are they selling it for free? Don't know. It's for free. You don't care. You don't care if it's poisonous. You see the guy on the street, and you're like, hey pal, how much? It's free. Can't you read the sign? And you're gonna be like, no, I am so thirsty, I can't even see straight. So basically, of course, you drink one glass of orange juice. Damn, that was good. Another glass of orange juice. Damn, that was good. And then you drink 3, 4, 5, and as you can see, the marginal rate keeps increasing after 4, 5. But then we reach a point, the maximum point. This is called the law of diminishing returns, or the law of marginal diminishing returns. You can apply this to any concept in life. I say not just in life. I don't mean just in your life, in anyone's life. You could talk about juice. You could talk about apples. You could talk about work. You could talk about studies. You could talk about, honestly, anything. So, back to the orange juice example. After you drink like 5, you're like, okay, man, I'm not so thirsty. But then you didn't realize it, but it's like he keeps giving you orange juice. He's like your grandma, basically. And you can't say no. So you're like, oh man, okay, fine, I'll drink 5 more glasses of orange juice. Now let me ask you a question. Do you think the 10th glass of orange juice will give you the same utility or satisfaction as the first glass, that when you were thirsty and you craved it? No, exactly. It would not give you the first. Now imagine the 50th. Now imagine the 100th. After that, I think you would rather stop having orange juice. I think you'd rather just vomit. I think you'd rather just have less juice, or no juice, in fact. That's why it starts going downward like this. Of course, you can keep extending the curve and it'll go down, but I'm just saying, I draw like only a small part of it. So we can talk about this in education too. The more you learn, the higher you go in education, the less knowledge you actually get. So you can talk about this in terms of time, education, or quantity consumed, and why. By the way, marginal doesn't mean just, by the way, I don't think you understand this. Marginal means one additional unit. Okay, it's not the benefit, that's marginal utility. Now, diminishing marginal returns means anything. You can apply this to any concept, man. Any concept, bro. This curve is, I think it's my favorite curve. Second to demand, actually. I love this curve so much. I could talk about this for hours, but I'm gonna stop. Now, this is important because of the the indifference curve. Now, I think we know any point on the line of the IC is the exact same. They give the same utility. Meaning, the marginal change in utility of X multiplied by the change into X plus the marginal change of Y into the change in Y is equal to 0, because they provide the same marginal utility everywhere. And this is important to get to the second concept, which is the equal. Man, it's so dark, I can't even see. Yeah, it's called the equal marginal principle. This formula is very important. Now, if you're given the utility of X and Y, of course, we get the marginal. You'll get the partial derivative of X, partial derivative of Y, and you'll divide them both by their own prices. And that way, you should be able to find the optimal amount, point A, where the budget line and the IC are the same. Yeah, this was a good lesson, and let me summarize this. So we get a lot of questions about this topic. So let's go. Quick summary. Budget line. I see they meet, and you want to find the point where utility is maximized with the level of income you have, and that's why we use this formula over here. MUX over the price of X is equal to MUY over the price of Y, which is the equal margin formula, or the equal marginal formula. I can't remember the name, and my book is too dark, so I can't even see. Corner solutions, basically your consumer preferences are so skewed that the rule where MRS is equal to the price ratio does not apply, and it's better for them to consume completely one of a single good. So like, let's just say vegan, plant-based products or meat-based products, they will obviously buy plant-based products the entire way through. So there you go. Yeah, that's it. So if you enjoyed the video, please do not leave a like. I don't need a like. All right. I just want you to know that I want a comment though. I want you guys to say how much you love economics, especially from Ali Ramadan, who comments on all my videos. Thank you, Ali Ramadan. I appreciate that. Even on the Christian videos, why is a Muslim commenting on my Christian videos? Even I'm confused. I don't know why he does it. And he actually watches a bit of it. He's like the only friend I have who actually watches my videos, aside from Ethan Romando. And by the way, Angshal Malik, I have no idea why I even gave him a shout out. Like, I mean, he doesn't even watch the videos. I have like no incentive, no economical incentive to shout him out. I don't know why I did it. But yeah, this is it. This is, I think, the most confusing part. But then there's obviously questions that come about this topic, and they can get quite confusing quite fast. So I would say, especially like compared to principles, microeconomics, you actually have to do a little bit of practice. It's more math-based, and you really have to also understand the concept. I mean, yes, you do have a multiple choice exam, but you still gotta understand the concept. That's why I make these videos. I make these videos, I mean, I'm selfish. I mainly make these videos for myself, to teach myself. But, hey, externalities, right? I'm teaching you, and if you're learning from what I'm saying, or if I'm providing any sort of value to you, we're good. The only videos I actually, really want to improve on is my preaching videos, but my teaching videos, I think they're doing pretty good. I want to be a teacher when I grow up, so, trying to improve on these skills, body language, communication is really important. And even my confidence too. I remember the first time I posted the video, by the way, 30 views. Why does it have so many views? 45 minutes. Yeah, either way, it was very easy. I just read off a book. I think it was pretty boring. Now I have whiteboard, standing up. Clearly, I'm still in the same fit. I wear the same thing every single time. Hope you guys don't get bored of it. But, hey, I just want to know that. I want you guys to know, if any of you guys are struggling with economics, I will personally help you. Me and my boy, ChatGPT, always good help to have. Professors, I was thinking about this actually. Professors or teachers, which do you guys think is better? I know I'm not going to get any comments, but maybe just think it in your head. Hey, do you think a professor's cooler or a teacher's cooler? Just think of all the pros and cons. That's all for today. Thanks.